Let's work an example. This is for the box fill calculation. We've got to determine what size box is going to be required for a 12-2 with ground Romex cable connected to a receptacle in a box with cable clamps installed. Now our box is going to come from the factory. That's going to have the cable clamps mounted inside the box. And our Romex cable will feed through like so. Now the question says that it is a 12-2 with ground Romex cable. This is the type of conductor that is used in wiring residential housing. The 12 here represents the size of the wire. That would be a 12 size American wire gauge copper conductor. The 2 means that there are 2 each conductors, and then with the ground means that it has a bare copper wire that is used for the grounding conductor. Step number 1. Step number 1 requires us to determine how many conductor equivalents and their size is going to be located in the box. We're going to start off with the conductor, the Romex cable. It says in the question that we have one receptacle supplied with a 12-2 with ground Romex cable. So step number 1, we're going to have a 12-2 with ground. This is going to count as 2 each 12 gauge conductors. The 12 here, remember, is 12 gauge. That's where this comes from. And then 2 means there's 2 conductors. So I've got to count that conductor as 2 cables. We'll deal with the ground in just a moment. Next, the box, you remember, had cable clamps. And Article 314.16 tells us that the clamp field for a box, we're going to count 1 each, or 1 conductor equivalent, and it's going to be sized at the largest conductor entering the box, which in this case is a 12 AWG. Now we're going to mount, there's going to be 1 receptacle mounted. The code book calls this a yoke, and for a yoke, or the receptacle, we are to count an equivalent of 2 conductors, and the size is going to be determined by the cable or the conductor that's connected to that receptacle, which in this case is 12 AWG, 12 gauge. Now we're going to deal with our ground wire. From up here, Article 314.16 tells us to count the grounds, 1 or more grounds in our box, as 1 equivalent conductor. That's going to be sized as the largest conductor in the box, which is 12 AWG. And I think that's all we need to count. So now what we're going to do is we're going to add these up. So we've got 2 plus 1 is 3, plus 2 is 5, plus 1. So basically I've got 6 each 12 gauge equivalent conductors that's going to be going in this box. Now I'm going to use table 314.16b, and we determined that we're going to have 6 equivalent conductors size 12 AWG. So looking at table 314.16b, you're going to find the size of conductor, which is 12 AWG, and you'll see that the volume of that size conductor equals 2.25 cubic inches. What we're going to do now is we're going to take this 2.25 cubic inches and multiply by 6 equivalent conductors, and we come up with a total volume of 13.5 cubic inches. We need a total volume of 13.5 cubic inches to accommodate everything we're putting into our box. So now I'm going to go to table 314.16a, and I'm going to go under the minimum volume column, under the cubic inches, and I'm going to come down this column until I find a number that's greater than or equal to 13.5 inches. Now, since I'm going to have a receptacle mounted here, I'm going to probably use a device box. And the first number I see in the cubic inch column under minimum volume that's greater than 13.5 cubic inches is 14. And that corresponds to a box that is 3 inches by 2 inches by 2 3/4 inches. And this is a device box. And that is how you calculate box fill.